I see my
Recording is on.
awesome. Okay, show me what is showing. Okay, can you guys see my screen now?
Yes.
Okay, this is hopefully that is what showing there. That's fine. So it will record. Okay. So last week we discussed this. I think both of you are there, right? Modit and and Tarun. Array tuple.
Yes.
So we talked about this algorithm given an array of integers and find a distinct tuple P and Q that sum up with this, right? So we completed that, and I think I shared the algorithm as well. I think we have a couple of solutions last week. Anyone got a chance to implement different solutions? So one is
So like I have tried it with the hash map. Yeah.
oh, very good. You tried with hash map.
I do.
Yeah.
Very good, very good. Yeah, share with that. I used a different technique here, right? So I sorted here manually and did it. So if you share that algorithm, I will update this code here. So there are different approaches to solve the problem. So now let's jump into the another one since we already discussed the other one. We already discussed that problem last time. So let's jump into the contiguous maxim. This is also very important and very many times in the interviews as well. I think this is called two sum problem. Check paper existing. No, this is not the one. Yeah, I'm talking about array G. Yeah, this is the one. So largest sum contiguous subarray. Okay, this is also called continuous algorithm. I don't know about this. I think that there is a name for this. So basically, given an array, this is already in the Geeks for Geeks. I gave the link. Anybody got a chance to look into this? There are a lot of solutions as well.
Sir, I went through it.
Oh, you went through it. Awesome. Very nice. You already know about this then. So how about Abhi, or maybe if you did not get a chance, we will go through this. No problem. So
Sorry.
no problem. So this is basically given an array of size n. The task is to find the sum of the contiguous subarray within array with the largest sum. What is that contiguous? Am I spelling correctly? Or contiguous means like it's a continuous, right? Basically, you subarray. So subarray means if you take few elements from the array, that is a subarray. But you have to take continuously, like you have to take from 4 to 5, like 4 - 1 2 1 5. So that's called contiguous. So you have to take a sequence of elements from the array, and that elements will give you the largest sum. Okay, so if you look at here, right? So if you take any other elements than these, like if you take 4 -1 2 1 5, what is happening here is if you sum all those, you will get 7. You will not get 7 if you take any of the other subarray. Even if you take the entire array, look at this 7, and if you have to -2 -3 and -3, so it will be another -8. So even if you sum entire array, you don't get 7, right? Because the other numbers are minus integers, negative numbers. So basically we need to find a subarray which gives you the largest or the maximum value. So anybody have any questions in understanding the problem, or are you clear? So we need to find the sum of contiguous subarray within it. So we need to basically the answer here is 7. So what is the maximum sum? Okay. Yeah. Is it clear to anyone? Like, is it clear? Is the problem is
Yeah.
clear?
Yes, sir.
Yes, sir.
Yes. Yes.
Very good, very good. So, how to find this? That is the main intention here. So look at let's see. Let me give you one of these examples here. Let's talk about this. Like, okay, I'm opening my uh, inking slate. This is what I use, and let's see. Let's take these numbers 0 1 2. Come on. 0, 1, 2, 7 minus 8, 6. Okay, it's a separate input I want to take. 7 minus 8, 6. 7 minus 8, 6. What will be the largest here? Like, what are the numbers? So, what will be the answer? So let's take like subarray means it could be more than one elements. You can also take one elements. Let's say one element like all the numbers are minus numbers and you have a big thousand here, right? All the numbers are minus. Let's say minus 18 here and minus 10 here, minus 11, and then you know if you take any of these numbers, it will decrease the value. So it's simply 1000 is the answer because you should not take any other element. All the numbers are negative numbers, right? If you take any one number, then it will become 1000 minus 1 or 1000 minus 10. So even in this case 1000 is subarray. There is no other in a subarray that will give you maximum, right? So similarly, subarray can be subarray can be it can be one element or more than one element. Okay, so but if you look at here, there are more than one integers. Definitely there is a bigger number than what is the bigger number here. So the bigger number here is, what is the big number here in this array? The biggest number,
7.
7, right? So 7 is there.
Yeah.
So definitely you will get more than 7 because there are other positive numbers, right? Now let's go with the native solution. Navy solution or native solution is basically, okay, let's start count or summing these two numbers. If you sum these two numbers, the answer is 1, right? If you continue the same thing, the answer will be 3, right? If you continue the same way, answer will be
Then
10. Now, if you continue the same way, what will happen? 10 minus 8, then the answer will become
2.
2. So then what is the problem? That then what you do? Oh, then don't count. Don't take this. What are we doing here is basically you are keep going until you are getting a big number. So 1 became 3, 3 became 10. That's fine. We can go because it is giving you the big number. But as soon as you get something which is making you less number, which is making you less, right? So then immediately you'll say, okay, stop there. Then you found some subarray. There is a subarray you found some from some index, let's say index x to index y, and the value of this is 10. From here to here, from this number to this number, the value is 10. We don't know whether that is a big. You should not announce that, hey, I found the biggest largest 10 is the answer. No, we don't know. We haven't scanned the other numbers yet. After 8, after minus 8, there will be another 10 numbers or 20 numbers or another 1000 numbers. We don't know, right? Since you are seeing here, there is another number called 6, right? So now what you do is now you can also do like two here. Okay, now if you continue, what will happen is, let's say you did not stop here, you continued. Okay, now the answer is 2. Let's sum the 6 as well. The answer is 8, right? If you sum all the elements, and what we are getting, we are basically getting number 8 is the answer, isn't it?
yes, sir.
Yes.
Which is less than what we already have here. That means it's not an ideal solution to take all the numbers all the way from 0 to 6. It's not an ideal number. It's not a good idea because you are not getting maximum number. You know that, right? Now, now let's go with any other, like, do we have any other solution like that? Now what we do is, let's start with, we already know, if you start with the index, if you start at index 0, and what is the index to get 10 here? So let's put some indexes here: 0, 1, 2, 3, 4, 5, right? So what we are doing is, basically we are marking the indexes. If you start at index 0 and if you end at index 3, you get 10. That's the maximum contiguous so far. Okay. Now the navy solution is, let's start with another. Let's start from 1. Let's start from, like, if you start from 1, 1 plus 2 becomes 3, and right, and 3 plus 7 becomes 10. Okay. Now that is also 10. Like, even if you take minus 8 becomes 2, and then 6. So basically this is also another array. You can also take from index 1 all the way to index 3. That is also 10. You can ignore first one, right? So now if you start from 2, what will happen? 2 plus 7, right, which is 9. Okay. Now 9 minus 8, which is 1. Now if you go further, 1 plus 6 equal to 7. Now there is no use, because the 7 is less than the actual value 10 here, isn't it? So it's not a good idea to take out the 1. Are you guys following? So in the navy solution, what you do is, you always you always start from the first element, and then start from the second element. You try to do that, right?
So we try to add it till end of the array, like start from 0 to like end of the array, then start with one index to end of the array.
Yeah. So basically we always do that, and try to find a subarray. That subarray sum is greater than the sum which we already have. We are going to store this, right? Basically we want to make sure, what is the current sum so far. This is the current sum so far. Current sum is 10, is the maximum one we found. And the how you got the 10? If you start from 0 to 1, that 0 to 2, 3, basically the index number 3, then you get the 10. So you will store that information, right? And then you compare with it. So far we found that so far the maximum sum is 10. If you find any big which is greater than the 10, then we will ignore this. Then you ignore this, and you take the, what is the maximum sum that you get. Let's say you got 15. Then if you get 15, then you need to say, hey, we got the max. So far the maximum sum is 15, but in order to get 15, you need to start from here, you need to end from here, you need to end here. That's the boundaries, right? So because there could be negative numbers, so that's why we always have to consider what is the starting point and ending point. Of course it did not ask in the question, but if you want to display those numbers, or if you want to display the indexes, hey, tell me what is the you know index, start index and end index of the subarray that you choose. It's always better to store these two indices as well. Okay. So what will be the answer here? I don't think we will get any other thing. Even if you start from 7, you will get what? You will get 7, right? Like 7 minus 8 minus 1, and plus minus 1 plus 6 equal to 5. So you don't get maximum number if you take any subarray. Okay. I think the answer will be here. Answer, the first question answer will be that. So let's take, we can check this. Okay. Let's run this. I don't show the algorithm yet. I will show the algorithm later. Let's see. So see that. Okay, let me scroll up. Yeah, maximum sum is 10, start index is 1, and end index is 3. It's saying start index 1 because there is no point of considering 0, because its value is 0, right? So that's why start index is 1 and end index is 3. Okay, you can think of as, let's say, people just standing on the line with their ranks or with their marks. Okay, all these are marks. You don't need to consider the first person because he got 0 marks. There is no point of considering that subarray. So you always need to consider from, so 1 to 3, like 1 to 7. So that's the indexes here. So index 1, index 2. So now if you look at the second algorithm, right? Like here, maximum sum is 14. Look at that. So it's starting index 4 and ending index 7. So how the 14 came here is, if you start from here, right? If you start from here, 4 plus 1, 5, and 5 minus 2, which is 3, and 3 minus 7, which becomes minus 4, and then 4 plus 5, right? It is going some like that. So but if you, the starting index is 4, it is saying it is better to start from here, 0, 1, 2, 3, 4. It better to start from here, 4 plus 8, and then, so the ending index is 7. Look at that, 0, 1, 2, 3, 4, 5, 6, 7. So if you take these, all these three, it is giving you the big number. See that now we are considering minus number 2. Look at that, 5 plus 3 becomes 13, right? And 13 minus 6 and plus 7, what will happen? You will get one more number, that's a 14. You got it? So now it's always better to take these two numbers, even though minus 6 is there, but there is a big number here. That's why this is the maximum. This is a subarray which give you the maximum. Are you guys getting?
Yes, sir.
Yeah, so that's how it is. So basically you will go as far as you can, and you, until now you will find it. So what is the maximum subarray? So if you want to navigate, I can also tell you again. So 4 1 minus 2, let's do it quickly, and I will tell you. So here is the 4 1 minus 2 minus 7 5 8 minus 7 5 8. Okay, now minus 6 7 minus 6 7 and minus 6. So now what we are doing is we are navigating from indexes. So 0 1 2 3 4 5 6 7 8. Okay, so now what we do is we start from, like, you can take something like I, or let's say, okay, these are the variables we have to take. Current sum, cs. What is the current sum? Okay, and start index, si, start index of the subarray, and end index. Just I'm giving you just a small one letter, variance here. Ei means end index, si means start index, cs means current sum. Okay, you can think yeah, I think a max sum, I think it's a, yeah, you can think of as a max sum. Okay, this is the max sum we got so far. In order to get this max sum, you have to start here, you have to end here. Okay, now in addition to that, you need to maintain current sum as well, cs. This is current sum. Okay, now let's put max sum to 0, and start index, even just blank or -1. Start index, we haven't started yet. Okay, current sum is 0. So now let's start from this index, I equal to 0. Okay, I equal to 0. So what you do is, basically you have to you have to go in a sequential way. So let me show you the, how the algorithm works. Okay, we let me, yeah, just going that, yeah, just I equal to 0. So now I equal to 0, what happens here is, if current sum is 0, yeah, what they're doing is current sum is equal to 0, and yeah, so basically current sum is 0 right now. Current sum is 0, right? Current sum is 0. Now if the current sum is 0, we have to make this as the current sum. Okay, 0 is the current sum, and start index, okay, start index is also the, so start index is 0 and index is 0. So we are just putting 0 everywhere. Now I equal to 1. Now I becomes 2. If I equal, no, I is 0, now I equal to 1. Basically you're looping from first element to the last element. Now what you do is, you have to sum these two elements, right? So now so far you put this 0 here, you put the 0 here in the current sum. Okay, now you have to add this current sum plus A of I. So basically what you need to do is current sum plus A of I. So that means so far you calculated the the sum of the values. Now what is the value of A of I? Value of A of I is 1. So far the current sum is 0, and the value of A of I is, oh, see, actually that I did a mistake here. Current sum will be 4, right? Are you guys following so far? I think I put a 0 here. It's not 0. First, when the I equal to 0, right? Let me start again. It's confusing. So when I equal to 0, okay? I equal to 0. If the I equal to 0, what is the A of I? A of I.
4.
A of I is 4. So what we need to do is, if the current sum is 0, okay? That's what the if condition saying here. If the current sum is 0 and A of I is greater than 0, make the current sum equal to A of I and current sum start index equal to I. This is the main logic. What we need to do is, if current sum is 0, you haven't started counting anything. Current sum is 0, and at the same time A of I is greater than 0. A of I is 4, right? Now that is the biggest so far. So that's why what you need to do is you need to update current sum current sum to current sum becomes 4. And in order to get the 4, where you start, you have to start from 0. Where you end, you have to end at 0. Okay, that's the one. Now what you need to do is, let's look at the algorithm. It is tough. Yeah. Current sum is less than 0, current sum equal to 0, and current sum is greater than result sum, and the result sum okay. So what we need to do is result start index, okay, result sum start index, and result sum and oh, I need to update. This is the result, yeah, you can say max sum or result sum. So it is saying like result sum, okay, result sum, and the start index of the result sum and index of the result sum. So now, okay, what we need to do is, you got the 4. Current sum is 4. Now you need to compare these two. Are you getting the big number than what you already have? Yes. The result sum is 0 because you haven't processed the array. Now you got the 4. Let's assume the rest of the numbers are minus numbers. Let's assume rest of the all the numbers like 4, after 4 everything is negative numbers. Then what will be the answer? 4 is the answer, correct? Isn't it?
Yes, sir.
Now that is the reason we are assuming, which since you haven't started navigating the array, we are assuming 4 is the result sum because that's the big number so far. We are assuming 4 is the result of the whole algorithm. And what is the starting point? In order to get 4, you need to start at 0, you need to end at 0. Okay, these four variables are very important. It's so in order to solve this problem, these are the four variables we always manipulate. Okay, now what you do is, now what happens here, you updated the result sum. Okay, now I becomes 1. When I becomes 1, what happens is, let me look at the algorithm. The algorithm is saying if current sum is 0, is current sum 0? No, current sum is 4. Then what you do is, you need to make current sum equal to current sum, that means 4 plus A of I. What will happen? 4 plus 1. 4 plus 1, 5. So the current sum becomes 5. Okay. So far, if you go from this side, if you go from first number and second number, if you are summing those two numbers, you are getting 5. Now you will check, is 5 bigger than the result sum so far? Is it bigger? Yes, right? So you are thinking
Yes.
4 is the answer. No, now we mistaken. Not 4 is the answer. 5 could be the answer. 5 could be the answer. Result sum could be the 5. Let's assume rest of the numbers are minus. Rest of all the right side numbers after 1 is negatives, then 5 is the answer. So let's assume that 5 is the answer, and in order to get 5, where you need to start? You need to start, you need to start. I think there is one more variable you needed. This is very complicated. Current sum start index. Yes, you need to take current sum start index as well. So current sum start index. Sorry, let me go back here. So we need to take current sum start index. So, so you started at 4. So you started at 0. So that's why your current sum start index is 0.
Yeah.
Okay. So you don't update this until here. So now what happens here is, in order to get 5, what you need to do is, you need to start from the current sum start index, and the end index is a of I. A of I is 1. That's how we do. In order to get 5, you need to start from the index 0, and you need to end at index 1. Then you will get 5, isn't it?
Yes, sir.
Now that we have to do all those. Now what you do is, now I becomes 2. Now whenever I becomes 2, this is a tricky thing. What will happen is, current sum is 5. Let's keep on adding 5 plus minus 2. This is what you do is, by before, this is what we exactly doing. By using our eyes, we are summing those numbers, and we are comparing it with our mind. We already have 5 in our mind. We already have 4 plus 1 is 5, and 5 minus 2 is 3. Then we stop there. Oh, don't take 2, right? So we are already doing in our mind, but you are putting 5 somewhere in your brain, but now you have to put it in a variable. That is what the difference here is. So you will get 3 here. 5 minus 2 equal to 3. Now, is it better to consider 3? No, because, so current sum became 3. Current sum became 3, which is not greater than 5, which is not greater than the result sum. So what you do is, in that situation, let's see what are we doing in the algorithm. If the current sum is 0, no, current sum is not 0. Current sum equal to current sum of g of I. Now current sum is greater than result sum. No, result sum is actually 5. Current sum is 3. So now we are not doing anything. We are simply going back and incrementing I. So basically we are incrementing I. So I becomes 3. Okay. Now what happens is, now we are keep we are keep incrementing the same thing. We are keep incrementing current sum. Is current sum equal to 0? No, current sum is not 0. Current sum is 3. Now let's do the other math. 3 plus a of I. A of I is
-7.
minus 7. So what happens here is minus 4. This is a tricky step again. So now what we are getting, current sum is minus 4. Okay. Now current sum became minus 4 here, and start index is again still 0. So if you start from 0 all the way to here, you get minus 4. That's what it is. But is it greater than what we have? We still maintain 501. Is it greater than 5?
No.
No, it's not greater. You simply go ahead and do the next one. That's what we do here, right? If you look at the algorithm is saying, is current sum less than 0? Oh, this is what it is. If the current sum is less than 0, we are setting the current sum to 0. That is very important step. So what we're doing is, we just summed the numbers. We got minus 4. Since minus 4 is less than 0, we are setting current sum to 0. That means we don't store we don't store minus 4. What we do is, we will store 0. Okay. I will tell you why we do this. Now I becomes 4. When I becomes 4, we will get 5, right? So what will happen here is, so now we will go back here. Is current sum 0? Yes, current sum is 0. That means if you there is no value of putting like summing all these. Let's see, if the current sum is 0 and a of I is greater than 0, yeah, we got a of I which is 5 greater than 0. Now change the current sum to that, and also change the current sum starting index. That means what we do is change the, so a of I is 5, a of 4 equal to 5, so we will set that current sum to 5. And in order to get 5, where we started at current sum start index equal to I. That means now in order to get 5, you can start at the index 4. You getting?
Yes, sir.
So previously, if you look at here, you can get 5 here. You can get 5 current sum 5, but in order to get 5, you need to start from 0, because so you have to say 4 plus 1. 4 plus 1 equal to 5. But here, look at here, it's already 5. The number is already 5. It's better to take that, right? That's why we are saying in order to get 5, you don't need to start from 0. Even if you start from 0, what will happen until here? It comes all the way here. It comes all the way here. Then it becomes minus 4. Minus 4 plus 5. There is no value of taking that, right? So until here it is 5. 5 minus 2 becomes 3, and 3 minus 7 becomes minus 4. So it is ultimately going to 0. That's why what we do is we don't consider the whole thing. Now what we do is, now we got another positive number which is 5. Let's see that gives a maximum number. That's why we are setting. Now we are exploring another new subarray. Very carefully understand this. So what we are doing is, so there is no value of considering all the way to here. We will consider these two values already. You get 5 here. If we start from 0 and 1, we already stored in our memory. In order to get 5, maximum so far is 5. In order to get 5, you start from 0 and end at 1. If you start from 0 and end at 1, you already get 5. Now we are exploring another subarray starting from 5. Let's see. Your starting index is 4 and current sum is 5. Let's see what happens. Okay. Now I becomes 5. Index 5. What is the A of I? Are you guys following? It's so complicated, I know. What is the A of I?
5,
A of 5. A of 5 is
8.
8. Exactly. So A of 5 is 8. Oops, what happened? Okay. Something happened. There is a zoom happened, I think. Okay, I need to zoom it here. Okay, so now E of I. So basically, current. Now what we need to do is E of I is 8. Let's look at them. Current sum equal to 0. No, current sum is 5. This is the current sum. Current sum is 5. Now what we do is current sum plus E of I. We have to sum those two numbers. Current sum equal to current sum plus E of I. That means 5 plus E of I is 8. 5 plus 8. 5 plus 8 equal to 13. So that's what the 13. Okay. Now what we do is 13. Okay. Now start index is still 4. We don't update start index. In order to get 13, you started at index 4. Okay. Now, now what we do is check the algorithm clearly. Okay. Is current sum greater than the result sum? So far, the result sum
Yes.
is 5. Yes, we found a very big number which is greater than the result so far. That means so far we found 5 is the answer. We are assuming 5 is the answer, and you start at 0 and end at 1, which is not the right. You will get 13. The current sum 13 is bigger than the result sum. Now what we do is, it is still continuing like this, but now what you do is, since this is bigger than the 5, what we do is we are resetting the result sum. We will say, hey, you will get, so here is what we do. Result sum equal to current sum In order to get that, result starting index equal to current starting index and result ending index equal to I. Very careful to understand these lines. So result sum equal to current sum. That means since this is bigger, we say, hey, you will get 13. When do you get 13? When you start from 4. That's what we do. 4. That's what we do here. Look at the next line. Result start index equal to current sum start index. That is the reason we are maintaining. Why we are maintaining this current sum start index? Because we want to know where you started. In order to get 13, we started at 4. We started at index 4 and we came all the way to 5. So now I value. What is the I value here? 5. Are you guys followed so far? It is very complicated algorithm we chose today. Is it clear?
Yes, sir.
Yes, sir.
I don't know why it is not. It should expand actually. Let's see if it expands. No, it's not expanding. That's fine. So that is the main intention here. So basically we always maintain these variables. So now let's look at the actual answer. This is not the final answer. 14 is the answer, right? I showed you the answer. We got the index, sum index equal to 14, start index equal to 4, end index equal to 7. How we got it? Because we will still continue, we don't stop here. So I becomes 6. When I becomes 6, what happens is, again we sum with the current sum. So current sum is 13 plus a of I is minus 6. What will happen? What is the answer here? 7, right? 7.
Yes, sir.
So 13 minus 6 is 7. So current sum became 7 and your still start index is 4. Now you compare these two. Is 7 is bigger than 13? No. 7 is not bigger than 13. So you don't update anything. But now what happens is I became 7. Now what will become? 7 plus the current sum is 7 plus a of I. A of I is 7. Now you got 14, isn't it? Now current
Yes, sir.
now current sum became 14. Now you got the big number. The result is you are assuming 13 is the biggest ever. Oh, you are assuming, hey, just start from here, just start from 4 and end with 5. 13, 5 plus 8, 5 plus 8 equal to 13. But that's not the result here. If you consider, even though the next guy got minus 6 marks, you have to consider the other people, the 7. In order to consider 7, if you consider 7, you will get bigger number. So 5 plus 8, you are thinking 13 is the bigger so far, and start at index 4 and at index 5. That's what you stored here. But our assumption is wrong. We got 14. In order to get 14, where you started? So we have update result equal to 14. Where you started? You still start at the same location 4, but end at ith location. You have to end at 7. That means you have to start from here and go all the way to here. You guys can see my pinkish kind of color. I keep changing the colors to identify. So in order to get 14, you have to start at the same location 4 and end at 7. Now we noticed. Now let's go to the last iteration. I becomes 8. What will happen? 14 plus minus 6. What will happen? What is the answer here? 8, right? Isn't it?
Yes, sir.
So 8 plus, like 14 minus 6 is 8, which is less than. So the current sum becomes 8, which is less than 14. Don't take anything because we already found a big number. So I becomes 9, and which exit the loop. Now you completed the whole algorithm and you got the result here. The result is in these three boxes. Result sum is 14, and you have to start at index 4 and you have to end at index 7. So this is the result sum. This is the result of the algorithm. I'm seeing like very silence here. Are you guys following so far, or is it confusing? Tarun, Modit, or any? It is so complicated, I know. So this is a complicated algorithm ever. I tried my best here. So basically, we took four variables. Okay, we keep track of those four variables in such a way that to find the exact proper subset of the array, subarray. I can't open this call here. Yeah, is it clear, Modit?
Sir, no issues so far, I guess.
Yeah, I like to hear from Tarun, Modit.
So I
Yeah, it's
understood.
yeah,
So it's
it's like confusing. Yeah.
It is confusing, I know. So, but when I'm going line by line, did you follow or no?
Yeah, Suresh. Yeah. Like I need to solve it by my like myself also. Yeah.
Yeah, yeah. So basic idea here is you will as you're going through the subarray, you keep track of those results. So when you start from zero, you say, hey, 4 is the answer. But what happens here is four is not correct answer. 5 is the answer here because you get 5 by starting from 0 to 1, right? So now what happens is whenever the value becomes negative, right? After here 5 minus 2 became 3. Whenever the value becomes negative, you reset back to 0. That's what we do here, right? So now became 3 here. The 3, and then 3 is fine, but 3 minus 7, what happens is 3 minus 7 minus 4. Whenever the minus 4, now we are resetting back to 0. And then you know you are taking the 5. So far, what is the 5? So next one is 5. So why we doing like that is, so whenever the current sum is 0, now you're resetting again because you already saved the values here. You already saved the value. You will get 5 by starting from 0 to 1. That is there in other variables. Now we are resetting 0, and then you are considering again from the 5, from the value 4, index 4. You are taking the values again because you are getting another positive number, isn't it? So here, if you sum
Yes.
all the way here, you got minus 4, right? Here is minus 4. There is no value of taking minus 4 into the consideration. That's why we are resetting, and you are starting again. You're starting again from the 5. Yeah. So that's the trick here. Okay. So these four variable, these 5 variables will help you to find out the correct subarray. So I can show the algorithm, and you guys can easily find out. So so here are different arrays. I'm sending all different kind of inputs. This is a kind of unit testing. Make sure your algorithm works for every algorithm, every kind of input. This input has couple of numbers. This has this has only one number, 0. And both are minus 1, minus 2. What will be the answer for this? Minus 1 and minus 2.
Is it only -1, sir?
Yeah, only minus 1. That's the maximum, right? And minus 1 means if you have to start at 0 and at 0.
0.
Yeah. And for minus 1 is also same thing, minus 1. And 2, for 2 1, what will be the answer for this? 2 1.
It's 3.
3 is the answer, and you need to start at 0 and end at 1. So the same thing for 1 and 2. Let's look at that. So after 7, here is the starting and ending. So maximum sum is 0 here for start index 0 and index 0. And the maximum sum is, where is 3 here? Maximum sum is 5. Oh, maybe am I doing correct? Okay, let's see. So let's go with array 3. Let's go with array 3. So I want to know. Let's test array 3. Okay. Array 3 is array 3 is maximum sum. Maximum 10. How come? Array contiguous subarray array A. Okay. I need to comment this line. Okay. So we are checking array 3. Okay. For array 3, what happens here is 0. So for array 3, white is 0. The result sum. Okay. Because I'm setting back to 0, that could be the reason. So because I'm setting the result sum is 0, right? So let's assume that if you have all minus values, the result is 0. So my algorithm is not properly solving for all negative values. See, we found a bug in our algorithm, I would say. So let's see for array 4, right? For array 4, it should give 3. Let's see. Yeah, array 4 3, start index equal to 0. Start index is start index is 0 and index is 1, which is good, right? And array 5, let's test the array 5. Array 5 is 1 2, which is also the same thing, right? Is somebody left the meeting?
Sir, I guess Mohit and Tarun left. It's only
Oh,
two of us.
I don't know. Yeah, okay. Is Ane still there?
Yes, sir.
Yes.
Okay, okay. Yeah, make sure that you're following, right? Are you able to
Yes, sir.
okay. So we are trying array 5. Let's see, array 5. Why array 5 we got 7? Interesting. Maybe am I running properly? Let me run again. Array 5, what's 7? What is 7? Why it is 7? Array 5 is just 1 and 2. Okay. Let's comment the other things. I'm not sure whether it's giving correct result. What? Maximum. It looks like it's not properly running. Oh, input. Okay, it's showing input. Huh? I need to show the. I need to get the output. Huh? Input. Okay. Okay, it's not working for some reason. For array 5, let's look for array 6. I don't know. It looks like there is an issue here. Oh, it is giving result. Yeah, array
Sir,
6.
I guess three fields to display, right?
Huh?
Sum as well as start index and index, like it's only printing one value.
Yeah, that's surprising to me. It has to print like this. So something happened.
Yes.
Something happened to this. Let me refresh the page. Okay, see the page. I'm refreshing the page.
Yes, sir.
But you guys understood the whole algorithm, right? Maintaining these variables is important. It is that we can also discuss the complexity in a minute. Just a minute. Let me make sure it's working properly.
Just a second, sir. Like, I have a doubt regarding this updating that current like start index. Like,
Yeah,
how is that updated? This current start index. Like, I know when when the like resultant sum goes into a negative, not the resultant sum, the current sum. When current sum goes to a negative value, we change the current start index.
yeah.
But to what value do we change it?
Yeah, let's discuss that. So basically what we do here is, so you're asking about when are we updating the current sum in start index, right? This one.
So, yeah.
So we will update whenever you get maximum not equal 0. So here is the current situation. If the current sum is 0, if the current sum is 0,
Okay.
come back, and a of I is greater than 0. So the current value what you are considering is greater than 0, and current sum is 0 for some reason. It could be the first iteration, or you set it as 0 in the latter
Okay.
iteration. Then what happens is current sum equal to a of I, and current sum
Okay.
starting is equal to I. In order to get this
Okay.
number, in order to get this current sum, you need to start from I,
Okay.
because you are resetting just now. You are just resetting the current sum. Current sum so far is 0. Okay.
Okay.
In order to get this current sum, which is greater than number, let's say this number is 5. In order to get the 5, you need to start at index I,
Okay.
because that's what you're taking, right?
Okay. So yes.
Yeah. Then you keep continue. This is the tricky here. So whenever the current sum becomes negative number, we are resetting to 0.
Okay, sir.
So yeah, if the current sum is not the 0, that means if it is not equal to 0, means definitely this is a positive number. There is no way this is a negative number, because if it is negative number, we are resetting, right? Definitely this
Yes,
is a
sir.
positive number, and we are incrementing the number. We are
Okay,
incrementing
sir. Yeah.
the value of a of I. After adding a of I, if this becomes negative, we are resetting to 0.
Okay. Okay. Yeah.
Whenever we reset to 0, next time what happens is it will take the next positive value.
Okay.
Yeah,
Yeah. I got it, sir.
yeah, awesome. So this is why it is not just displaying the result. I'm not sure. Uh, it's not. Is assigned value but never used. Here is assigned value never used. So what? It has to display the result. Why it's not displaying result? Interesting. Okay, very curious. Maybe I have, actually I some most of these algorithms I have in my Visual Studio as well. I will try to open in the Visual Studio. Okay. Anyone can guess? I think only two of you, Annie and Abe. Can you guess what is the complexity of this algorithm? Time complexity,
Uh,
space complexity,
so we got a fencer.
For open.
order of n. Very good. Why it is order of n?
There is no
So,
repetitive loops or anything. Like yeah, no nested loops or anything. Like
Exactly.
only there's only one.
so we look for each sum for each loop.
Yep, that's right. So we are looping only one time with a clever variable maintenance of these variables. We are cleverly, maintaining or only navigating once. Yeah, it's the order of n for the time complexity. What about the space complexity?
Space complexity. That's also n, right?
Are you sure when it is n? If you say order of n,
Not sh-
are we
not
taking,
that sure about.
what's that? Go ahead.
I'm not that sure about space complexity.
Yeah. So if you say space complexity
I
equal
don't
to
know how
n,
that works.
if you say space complexity n, that means we are taking n number of spaces. Are we taking n number of spaces or n number of variables? Let's say, how many values here? We have 9 values. right? Are we taking a hash table of
Yes.
9 or a graph of 9 or stack of 9 variables here?
Uh,
No, sir.
no, sir.
We did not take any additional array. We did not take any hash tables. We did not take any, any other stack or something. We are not putting all the elements in some other data structure.
Yes, sir.
So we are always taking these four variables. Four or five variables. Of course, including I, you can take six variables, right? These are five variables on the
Yes.
table, and I is the sixth variable. So
Yeah.
irrespective of the input, we always take six variables. You give 10 elements, you give million elements, you give 1,000 elements. I don't care about the n. Okay, I always take six
Yeah.
variables. I don't need any extra space than the space for six variables.
Yeah. Okay, sir.
Okay, sir.
Like, sir, just a second. Like, where is the six variables, right? That's four. Which are those six
Five
variables?
variables.
Or is
Five
it
and
five?
about I.
Five.
What about I?
Oh,
Okay. Okay. Okay.
okay.
I is also
Okay,
there,
sir.
right?
Yes, sir. Yeah.
Just
So
just
we only take the space declared variables. Is that right?
Yeah, space complexity, you can think of, how many variables are we taking. Now, if you look at these are
Okay.
the one, two, three, four, five, and 6. There are six variables here, and we are not taking any other data structure, right? Other than these
Okay,
variables,
sir.
are we
Yeah.
taking any array, any extra array? No. Are we taking any extra hash table? No. Are we taking any extra stacks or queues? No, right? So,
Yes, sir.
Yes, sir.
irrespective of the length of the array could be 10 elements or 1,000 elements. I don't care. I need a space in your device. If this the algorithm is running on a mobile, let's say I want a space, just a small amount of space in your RAM, which can maintain six variables is enough. I can run my algorithm.
Okay,
I,
sir.
I don't
So,
say,
sir,
hey,
there is no need to
RAM.
consider this array size or anything. Is that like there's not at all a need to consider the array size. Like it also consumes memory, right?
So the array is input. Input is there. So input we never consider the space of the input,
Okay, sir. Yeah.
because input may vary. Input sometimes you will get 5, sometimes you will get 10. So without input you can't run. This is inputs. The space for input is not your responsibility, right?
Okay. Okay, sir. Yeah.
See, you need to write an algorithm which is very efficient without taking any additional storage than necessary. If you are taking another array here, a subarray, or if you are taking any hash table, that is not an efficient solution,
Yes, sir. I get it.
Oh,
because you are putting and you are duplicating, you are unnecessarily putting all the elements into another data structure. So if the device where your algorithm is running has a very limited storage, your algorithm will fail because no memory available. So you are writing an algorithm which is a very efficient, just a very small space, only six variables. A space for six variables is enough. As long as you can create these six variables in the RAM, your algorithm will work. Correct, right?
yes, sir.
So,
Yeah.
irrespective of the inputs, you always take six variables. If you are increasing the number of elements, if you are increasing number of variables, let's say for 10 elements, six variables or six memory spaces. For 1,000 elements, 100 memory spaces. You are increasing your, then you can say order of n, because you are increasing your spaces, you are increasing your memory